Hello and welcome back to the course on deep learning. Today we're talking about sparse autoencoders. So, as we previously discussed, we are aiming to create an autoencoder where the hidden layer is actually greater than the input layer. And the reason for that is we want to extract more features, and we know that autoencoders are designed as a great feature extraction tool, and the whole concept is pretty solid when we want our outputs to equate to our inputs. But in this case, we want to extract more features than just 3 or just 2, or we want to extract an unrestricted amount of features. And here, what we're seeing is that basically, as soon as we do that, the autoencoder can cheat. It can basically just take these inputs, put them through the hidden layer, and then put them as outputs, and without actually creating any valuable feature extraction tool within itself during the training process, just because it's going to be easier for the autoencoder to do this. And so we have to come up with a way to prevent it from doing that. And the first way we're looking at is called the sparse autoencoder. And what I wanted to mention here is that you will hear sparse autoencoder a lot, like a lot. It is used everywhere, or pretty much everywhere in literature, and very often you will just hear sparse autoencoder and people won't even explain why it's a sparse autoencoder, what that means, and it just is sometimes even used interchangeably with an autoencoder. As soon as you notice that, you have to be aware of what you're dealing with. You're dealing with not the autoencoder that we were working with before, but this type of autoencoder, and that's why this tutorial is so important. So what is a sparse autoencoder? A sparse autoencoder is an autoencoder which looks like this, where the hidden layer is greater than the input layer, but a regularization technique which introduces sparsity has been applied. A regularization technique basically means something that helps prevent overfitting or stabilizes the algorithm. In this case, if it was just sending the values through, it would be overfitting in a way, and therefore we need regularization techniques, and this sparse autoencoders is one of them. And basically what it does is it just says, it introduces a constraint on the loss function, or a penalty on the loss function, and which doesn't allow the autoencoder to use all of its hidden layer every single time. So every time, or any time at all. So at any time, the autoencoder can only use a certain number of nodes from its hidden layer. For instance, it can use 2 nodes in this case. And so when the values go through, these nodes are outputting very, very small values, or very tiny values which are insignificant. So it's outputting insignificant values, and therefore only these nodes are actually participating. Then in another pass, these nodes will be participating. Another pass, these nodes will be participating. So you are extracting features. The essence is that you are, at the end of the day, because you have so many rows in your data set that are going through, at the end of the day, you are training this whole layer. So you are extracting features from each one of these nodes, through each one of these nodes, but at the same time, not at any given pass, you're not using all of these. So the autoencoder cannot cheat, because even though it has more nodes in the hidden layer than in the input layer, it is not able to use all of them at any given pass. And that's how the sparse autoencoder works. Pretty straightforward technique. Of course, it has mathematics behind it, and we'll just now look through some further reading that you can do. But in essence, it's quite a simple idea, quite a straightforward idea to still keep the large size of the hidden layer, but at the same time, not allow the autoencoder to bypass the proper training that we want it to undergo. And that's what a sparse autoencoder is. So whenever you hear sparse autoencoders, just remember that it's this kind of thing. And in reality, when you think about it, it is still compressing the information, but just every time it's using different nodes. Okay, so let's have a look at the additional reading. So we've got a interesting tutorial here by Chris McCormick. It's called Deep Learning Tutorial Sparse Autoencoder, and this is a MATLAB tutorial. So if there's any fans of MATLAB, if you're a fan of MATLAB, you might find this interesting. He walks you through how to do it in MATLAB. But other than that, I like it because there's some introductory mathematics, not too complex, but some basic level formulas which allow you to gently get introduced to the mathematics behind the sparse autoencoders if you want to, and understand how that whole how the equations work which don't allow the autoencoder to switch on all of its nodes at the same time at any given point, at any given pass. The next one is called Deep Learning Sparse AutoEncoders by Eric Wilkinson. It's a very short blog post on the essence of sparse autoencoders. It's literally like a 5 to 10 minute read, and just another gentle introduction to the world of sparse autoencoders. And finally, a very strong, powerful, heavy artillery paper on sparse autoencoders. It's called K-Sparse AutoEncoders by Alireza Makhzani, 2014. And it basically takes this whole sparse autoencoder concept to a whole new level, where it talks about different, like a parameter K, which allows you to control the sparsity of the autoencoder. And you got some examples over here on the right. You might find this paper interesting if you want to learn more about sparse encoders. I actually would encourage you to learn a bit more, because it is a tool that is used all over the place and it's constantly mentioned. So you will definitely come across sparse autoencoders if you are going to be dealing with autoencoders. Okay, so that's sparse autoencoders, and I look forward to seeing you next time. Until then, enjoy deep learning.